Okay, so we've got to find the positions of vectors q and r so that the 3 points are collinear. Collinear means make a straight line. And the approach we're going to use is we're going to create a pointer vector from P, which is the fixed point we know, towards Q, and a vector from P to R. Those vectors, so P to Q and P to R, must be parallel. And that means that whatever the result is of PQ, PR is going to be some number of it. So PQ equals some value K times PR. So this is still a vector equation of the line. So vector PQ. We're starting at P, so we go minus the P and add on the Q. So 4 minus 3. Go from the P, we're minusing the 2, but we're going along the 3. And we're going from minus, we're minusing the 4, and we're beginning with C. So this is the vector PQ. Remember, these are OP, OQ. So we have to reverse P. PO equals minus OP. And this is OQ. So what we've effectively done is PO plus OQ to give us this vector. Do the same thing for PR. So again, we're starting with R, which is going to be A, 4, and minus 6. And we're going to subtract from it our starting point, the 3, the 2, and the 4. Same idea as we did before. Let's simplify the expressions. So we've got 1, 1, and C minus 4. And we've got here A minus 3, 2, and minus 10. So for these to be parallel, we need to find a value that will scale to give PQ the same as PR. So it's K times 1, 1, C minus 4 is going to equal A minus 3, 2, minus 10. If you look at those values, if we look at the J direction, we get K is equal to 2. So now we know that these values are going into I. So in the I direction, we're going to have 2 times 1 is equal to A minus 3. So this is going to be A is 5. And when we do K, we get 2 times C minus 4. And that must equal minus 10. So C value is going to be 2C minus 8 equals minus 10. So C equals minus 2C equals minus 2. C equals minus 1. So what we're now saying is the vectors 3, 2, and 4, which is P, OQ is 4, 3, and minus 1, and OR is the A is 5, 4, and minus 6 are collinear. And we did that by finding parallel vectors. And again, I've put them into GeoGebra so we can see the 3 vectors in are forming a line. The vector C, the orange one, is my OP. The reddish one, which is dipping below, is the 4, 3, minus 1. And after all the rearrangement, we've got 5, 4, minus 6 is the black vector at the bottom. And as you spin it around, you can see they all sit on the same vector line. we wanted to find the vector equation, we could actually use any one of those points and find one of those pointers. So we could actually find one of these as a pointer. So this would be -5. 1, 1, -5 is the pointer vector. So let's write the line. And the line could be written as R equals the 3, 2, 4 plus lambda times, and it's either the 1, 1 -5 by using C is -5, or we could use another point, say Q, 4, 3, -1. It doesn't matter what the starting one of these vectors is, and it doesn't matter which one of these other lines we're using. So A, so this is 2, 2, -10. And as you can see, the pointer vectors are scales of each other.